All right, thank you everyone. I want to thank everyone for having me come here today, and I kind of struggled with the term or a title for this talk, and I guess the best way to bring this up is, my big thing is, just to start off, I hate the word drone. I can't stand that word. Drone is a type of UAV that shoots out missiles and it kills people. It's like calling every single airplane out there a Cessna. And then, of course, the other word for drone is a male that does nothing and he gets kicked out of his house for not working. So, I also want to talk to you a little bit about the UAS program at UW-EC and just give you an idea of what we have going on at UW-EC that distinguishes us from so many other UAV programs or UAS programs in the country. The photo that you're looking at is us having a little fun in a photo. It's after we went out and flew a variety of aircraft. And it's a field methods class, and about the field methods class, I think Martin Gable was here this day because I just used it as an excuse to put cameras on rockets even. So we were shooting rockets up in the sky with cameras on them, and it was a grand old time. But our UAS program at UW-EC it came out of a component of the growth initiative. And the PI on that was my wife, Christina Hupy, who has an innate ability to herd cats. I mean, me being able to work with UAS is in many ways me being very lucky to be in the situation that I'm in. Because I have a wife who is a stellar GIS analyst. She has the ability to herd cats, but not only that, I'm in a program that has personalities such as Peter Strand to take over the duties of Christina Hupy while she's doing these other things, and Martin Gable, who is a very, very good geospatial technology facilitator, and in many ways, he was able to set up so many of these different things in the backdrop for me just to be able to tinker with this stuff. And then, of course, I'll get into this in a little bit, but I have the ability to move beyond proprietary UAVs, UASs, and use open source and do a little bit of building from the ground up, because I also am lucky enough to have a former Navy mechanic who's very big into RC, who is the technician on the grant. And so out of the whole purpose of the Growth Education Initiative, there's actually a few partners in this room who are on this, is basically to provide our students with the necessary marketable skills to enter the geospatial job market. And one of the rising trends that we saw in the geospatial industry was unmanned aerial systems. And so out of that grant, we have about $60,000 for unmanned aerial systems in terms of equipment. It's designed to fit within the ongoing development of a geospatial science and technology major. So we have to go through the whole UW system, but the whole idea is that we're developing a major that's not where the students are taking GIS classes within geography. They're taking a major where they are taking information systems classes, they're taking computer programming classes, and they're getting a very, very wide array of what makes a true GIS analyst. And within that major, what we decided to do was make something. We didn't really want to have it where UAS classes were part of the major, but we decided to make a UAS certificate. In many ways, the same way that we have a certificate program right now. We said, let's make a UAS certificate, let's partner up with physics, let's get it to where they understand some of the stuff with telemetry, how they can understand a lot of stuff with battery technology, how to solder, how to do these things, to where even if you are a really strong GIS person and you go and work for a company and you have these skills and that craft goes down in the field and you need to make a quick fix, it's a very good thing to understand. We're not an engineering program. I'm not an engineer. In fact, my background in how I got into UAVs in the first place is I still would and do, I guess. for my dissertation, I looked at how battlefields recover from explosive munitions. And when I was dodging unexploded shells in Quezon, Vietnam, and had leeches all over me, I said there's got to be a better way to survey this data than tromping around in elephant grass. And lo and behold, I started tinkering and throwing cameras on balloons and kites, and here I am right now. So that's the gist of it. Our overall goal of the UAS program is to teach students proper UAS protocol. Now, if I said that I was going to teach the Geospatial Ethics class in our department, everyone would laugh at me. But at the same time, I am a big proponent of ethics when it comes to UAS, and every time I hear about someone flying a drone around the Space Needle, I wince, because that is not good geospatial ethics. And putting a GoPro on an RC platform is not a proper and ample use of UAS technology. In fact, you're not even getting anything out of it. It's just, there's so much more you can do, and there's so much more good you can do it. My other big thing that I want to teach students is the proper procedures. The proper procedures in terms of the workflows of preparing to go into the field, how to maintain the equipment, how to deal with the equipment afterwards, how to have a proper flight plan, how to engage in the operations in the field, what equipment to use overall, and that of course also relates to safety. As well as we're going to be teaching best use practices, so the best sensors and platforms for the application. This is something that I noticed a lot. I will say that Christina Hupy and I also do consulting on the side for a variety of different businesses when it comes to UAS, and what we often come across is the overkill factor, to where we were involved with doing some work on a Navy bombing range, and they want 3-centimeter resolution over 8,000 acres. And we were just going, no, that's not needed. But sometimes it's just, if you have the ability, if people want to, and that's not always the case. And then the other thing is that true color is not always what you want. Sometimes you want the near IR, and then we also like to teach people that there's different indexes than just NDVI. So that's one of the things and that gets back into, we're not going to be an engineering program. I'm not an engineer. My big thing is I want to really harness the power of an unmanned aerial system. I want to bring forward its true economic value. And then finally, we want to get into the post-processing of UAS data. And this gets into where we want to look at how is it best delivered? How do you best package this up and deliver it? How can it be combined within a geographic information system? Right now, another big issue, especially within the agricultural industry, is that you have growers and they're purchasing these unmanned aerial systems, and then they have all this imagery, and then they realize, whoa, my computer does not have 64 gigabytes of RAM, and it does not have the number of processors needed to crunch this stuff. And now when I have it, what do I do with it? And so this is another thing, is that we want to be able to have our students show how you can integrate that and place it within the context of other forms of data. And I mean, I can go on in terms of how this can relate to insurance agency and every industry and everything. So just to give you a timeline of pertinent events, just a little bit of background on where we are with this is, in spring of 2013 is when I first began deploying sensors on kites and balloons in a field methods class. And once again, I owe a huge amount of gratitude to Martin Gadel, because he was constantly helping me out in terms of just helping me get together equipment and gear and keeping my head on straight with that. In fall of 2013, via our consulting services, I was sent through a company called MTSI down to Texas to get training on a Robata supernova. And I was lucky enough to get trained by an individual named Gene Robinson. Gene Robinson is, he's often actually covered in the national news. He was just recently on CBS. He put out a UAV to look for a missing woman. I think it was outside of Fort Worth. And we're lucky enough at the university to actually have Gene Robinson come up as our keynote speaker on November 20th. So if anyone is going to be in the Eau Claire area and you're looking to talk to someone who is actually the person to know anything and everything with what's going on with the FAA, Gene Robinson is the person to talk to. Very, very wonderful individual. In spring of 2014, I purchased a 3D robotics Y6 with my own personal funds and decided to just start using it in the field methods class. In June 2014, we received the positive news of the GEI grant and we began purchasing equipment. And so I'm on sabbatical right now, but I only wish I could have done my original sabbatical of writing an encyclopedia on impacts of war on the environment, but I'm now involved in all sorts of new things. From June to present, we've been building and testing the UAS fleet. That's a few of the items over there. In spring of 2015, I plan on bringing more of the unmanned aerial systems into the field methods class, and then finally in fall 2015, there'll be the initial offering of the UAS class at UW-Eau. So here is a picture of that very craft right there, and it's not looking good. And so I have here what I have learned, and often the hard way. Because doing UAS safely and right, there are, especially if you're building something and you're going with open source and you're not getting something out of the box, there's a lot of hurdles that I came across, and they didn't often have to be there. And first of all, what I'll tell you right here and now is that do not ever, after testing a plane once or twice, think that you have it all down and put a $5,000 ozone sensor in the plane and have the professor whose sensor it is there with you. Not a good idea. Slight platform malfunction. So, to talk about the components of an unmanned aerial system, this is Max, and he's right there. This is actually pretty funny. This is Max's. He's Mad Max. He's a mad scientist, but he built this self-tracking antenna, and those are his first-person view goggles. He built that from parts he got on eBay, and apparently he found somebody in Russia who was selling used cell phone tower parts. And he built this self-tracking antenna, and it worked. It worked phenomenally. But an unmanned aerial system, what I really want to stress is that there's a big difference between an RC plane and a true unmanned aerial system that has autonomous flight. And what's unfortunate is that this is what's happened. And so the drone that you saw flying around in Seattle around the Space Needle was no more than just an RC plane that somebody probably had first-person view goggles on. What's happened with the world of RC, though, is that the sensors have gotten so small and the technology has gotten so user-friendly, not to mention that computers have become sophisticated enough to have a really, really nice simulator software on them, is that it's gotten cheap enough for a lot more people to utilize these. It used to be that RC was relegated to a very small number of people, and there was a very steep learning curve, and if you crashed that RC plane, you were out of a lot of money. Not to mention, it wasn't until recent developments in battery technology that you could even get an RC plane that had anything but gasoline-powered motors. But what's happened is that with the ability now to use first-person view, with the ability now to have these little micro cameras on board, now you have a lot more people who are able to use a technology that before was just not as accessible. But within an unmanned aerial system, and the reason why they're called an unmanned aerial system is it's no different than why you call it a geographic information system. Because many people in here have probably been very frustrated with other people when they make a map on the computer, whether it be in Photoshop or whatnot, and then call that GIS. Because everyone in this room would very much agree, I'm sure there's many different derivations of what truly constitutes a geographic information system, but my big thing is that you have to have that database component to it. Well, it's the same thing with the UAS, is that the platform is actually one of the cheapest parts. That you can get a $60 plane on the internet and turn it into a truly autonomous flight bird. The platform is what is flying. That's where the aeronautical engineering comes in. Then you have your sensors. Now your sensors are what is gonna start making that thing into something that goes beyond a hobby. And this is where the money making is going to be coming into it, or the research capabilities go into it. And the sensor does not need to be imagery. I was talking about that ozone sensor. You can put air quality sensors on these things. You can put ozone sensors on these. You can put a variety of different sensors on there, and they also don't have to be true color. I mean, what's going on in the realm of thermal infrared is becoming truly astounding, and how these thermal IR cameras are getting smaller and smaller as well. And so when you think about these platforms and you think about the sensors, you start thinking about how those applications might start relating to geospatial technology. I believe Adam and I might have been discussing bridge inspections. That's a big one, is that why are we putting people and having them dangle out beside the bridges when we can put these right sensors on there and we can detect these cracks in these bridges a lot better? It's just you want to know the right sensor. Now, where we get into making this into a true unmanned aerial system is where we start getting into the autopilot hardware. And that's where the flight controller comes into play. And the flight controller is the brain. This is where you're going to start significantly increasing the cost of your unmanned aerial system. Where when you start putting that thing on board, you're going from having something that you can buy off the internet for under $100 many times into something that is going to cost more. Although I know that the Chinese, I believe, if you go to Hupy, you can pretty much buy the 3D robotics make something called the APM, and now they have something new called the Pixar, but for $82 you can buy a flight controller off of Hupy. So that cost has gone down significantly. And then of course you have your GPS. And when the flight controller, or that central computer, the brain of the elephant, is communicating with the GPS, and it's communicating with these other sensors on board the flight controller, such as accelerometers, gyroscopes, all these different devices that can tell the device where it's at in space, now you have something that is going to be capable of autonomous flight. But it has to be able to communicate with something on the ground. And so this is where your ground station comes in. Now your ground station, you're going to want to have a laptop. In this case, this is what I was using with MTSI out in China Lake. This is a proprietary software. This is the Robota software. A very popular open source software that I like to use is called Mission Planner. And when those things are on the ground station, you use that and you put in the flight path of what you have. There's a lot of different functionalities that you can have in there. You can say what the field of view of your camera is. You can specify how much overlap you want between your imagery. Because in order for you to orthorectify an image, you generally need 60% lateral and 75% longitudinal overlap. And that's how you can generate the point cloud to make the orthorectified imagery. But that ground station, you have a modem on there. And that modem, the price goes up according to what kind of range you want. But what you can do is that ground station then communicates with the plane while it's in flight, and then you can see where it is in the air during its flights. And then finally you want your radio control. Your radio control goes back into that RC. And the radio control is, of course, you have your transmitter, which is in the car right now. I'll go get that afterwards to talk. And then you have your receiver. Now in this case right here, this is the receiver, and this is what would communicate, and I can put the other wing on there, but this receiver is what's communicating with the transmitter, and that's the device that the pilot, that the controls would have with the RC controller. And this is the receiver on here. So all those components, as well as having first-person view, and I'll talk to you about first-person view in a second, because one of the things the FAA is looking to do is ban first-person view, and to me that's a really big mistake, because it's a really great safety component. It gets into that fail-safe redundancies. And first-person view is, it's these goggles that Max doesn't have them on, but when you wear those, it's the Call of Duty game, to where you're seeing what the platform is seeing, and you don't have to have eyes on it. Although if you lose your eyes on that bird and you lose your telemetry with your first-person view, not good. So you want to know the platform for the application. You might recognize this platform right here. It's the one right there. It's been souped up a little since this flight. We didn't have all those gizmos on it because we were kind of vetting a lot of stuff, and we didn't want to have any problems. But when you start looking at these different platforms, you want to think about the application that you're doing. And the first one that you might think of is the fixed wing. And so the fixed wing is your airplane, if you would. And the plane is good for doing large areas. And if you're going to be doing a large area, you have a really nice open area for launching and landing, a plane is a really good choice. But what a lot of people tend to move towards is the rotorcraft, which is good, but sometimes, especially in agricultural applications, it's often you're better off with the plane. Now with the fixed wings, though, you have your flying wing, and the flying wing it's like the B-2 bomber. It's a wing design. It's not your traditional design that you think of like the Cessna airplane. The other style is, and this is what I used out in China Lake at that bombing range, is the trainer style, and that's where you have, it looks more or less like a Cessna aircraft. Now the nice thing about those is that they fly really gentle, they fly nice and stable, but they don't do well in high winds. The flying wing, especially when they're really big, they can cut through the wind like a knife. And I've had that RV jet out in some pretty crazy winds, and it's done quite well. Rotorcraft, you can have a single prop helicopter. Now, single prop helicopters, a lot of, I shouldn't say a lot of, but there's researchers that really like single prop helicopters, and I'm not talking about the little SIMA indoor RC helicopters. These are the ones that have rotors as big in diameter as that. They're super, super dangerous though, but the nice thing with these is that they're a lot more stable in flight, they can fly pretty fast, and they're much more efficient in terms of flight time. There's a guy at Central Michigan University that has I think he has a hyperspectral scanner that he deploys on, and he does wetland delineation with it. And he got that because he needed to be able to fly incredibly well at the same exact speed and at the exact same altitude, and he couldn't be buffeted at all by winds. Now, I also throw on there balloon and kite, because this is where I started doing this, and I actually had a poster at, well, I know that there was just a session that wasn't very, at Esri, I hope I don't get thrown out, but I was at Esri and I had a poster on this, and the balloon is actually a really great platform for taking imagery. And if you have an open space and you literally just want to get pictures of, gee mom, this is what my house looks like from above, or I want to see what my garden looks like, putting a balloon in the air and then attaching a camera to it, especially if you get something called a Picabay rig, is quite nice. Martin knows there is some snafus involved with that, but other than that. And then the other one that's even more stable than a balloon is a kite. Now, I'm not talking about a little kite. You can get these that have a 9-foot span on them, and once you get them up in the air, even in really, in fact, the higher the wind, the better they do. they're stable as a rock. And what you just do is you get that kite up in the air about 60 feet, you attach your camera to it, and then you put it up the rest of the way. You put your Canon camera on there that you have a kit where it'll take pictures continuously, or GoPro will do that now, and you're good to go. If you're not looking to do anything too hardcore and analytical. I mean, I sometimes miss putting my kite in the air. I think I might go home and do it just because I miss it so much. But before you get an unmanned aerial system, there's some questions you want to ask. And the questions you want to ask is, first of all, do you build your own or do you build it out of the box? There's just like with open source software, there's benefits and drawbacks to either. If you build your own, there's going to be lots of crying involved, and for everyone in here who's been frustrated back in the days of command prompt, ArcInfo, or writing that script, and you're beating your head over and over again, multiply that by 100, because that's what it's like building your own, but at the same time, it's very, very cheap. And I can give you an idea. This thing right here, it's if you were to buy the foam airplane on Hobby King, you're going to spend about, I don't know, $90 on that foam plane. But because it's proprietary software, because it's out of the box, this thing costs a little over $10,000. And you look at this and you go, why would something like that cost over $10,000? It literally is, there's nothing spectacular about it. But at the same time, there's none of those other headaches. Now, like, once again, I'm lucky enough to have someone like Max who's involved with building our own. And in all actuality, I just went to Gene Robinson and asked him if we can get one of his proprietary systems, just because of the flight times and everything that it had. And plus, within the teaching component of it, I'd like to be able to tell my students, okay, you have your proprietary, let's use this, and we also have our open source. Let's look at the pros and cons of either. Another thing to consider is the material. And when you buy these planes, the first thing I'll say is that especially if you're building your own or if you're just starting, it's not if you're going to crash, it's when. Foam is amazing because hot glue fixes anything. No, I'm not kidding you. So remember that picture of the plane that was all beaten up? That's that plane right there. And I was holding my head and I was just going, oh, I'm gonna have to get a new fuselage, which really isn't that much because it's foam. And that's what's the other thing is it is too bad. You can always very cheap. Oftentimes in a crash, the sensors live, and unless you crash into water, the sensors live, and it's just the actual platform that's damaged. And if it's foam, it's really cheap. But even then, if you have hot glue on hand, it can be fixed. And that thing has more hot glue in it than the Bionic Man. So before flying your UAS, now this is a great, because this is up near Drummond, Wisconsin. This is an ecologist at UW-Platteville who's looking at earthworm invasions. And we put a near IR camera on here. And lo and behold, you can see the stress associated with the earthworm invasion front. But what was going on here is that we pushed the limits on this thing, and it was on its return flight, and all of a sudden it just dropped out of the air like a stone. But it landed, if there was ever a place for it to land that was better, it would have been this. It wouldn't have, or this is the best place because it's a bog. It's a bog, and so it's filled with just this beautiful, squishy, puffy moss. And so it dropped out of the air like a stone, and I sent out Max with his search and rescue UAV, and he was flying first person, and then once he locates it, he just does a holding pattern over it. And then I just went and got it, and I just picked it up and dusted a little bit of lichen, a little bit of sphagnum moss off it, and it was good to go. So before flying your UAS, number one rule, do not solely rely upon autopilot. And I will say right now, there are a lot of vendors out there who will sell you a platform and they will tell you, we'll train you in a day. And it's as easy as pushing a button. And that's not good. It's not good for the ethical component in terms of how much people are nervous about unmanned aerial systems, and it's not good for your pocketbook. I was in Vienna giving a talk this past, January, and the guy at the Vienna University of Vienna was telling me how they had a UAV. And then he didn't really give me any details on it. And then later on, this lady came in there and she goes, "Oh, did Thomas tell you about the UAV?" And they went, "Yeah, they were out in the mountains and it was flying, and then it kept on flying and they just waved goodbye." And that's what it is. They had they just bought something to where they just plugged in the waypoints, and they didn't take into account, hey, we're in a mountain, there's all these big objects that can block signals. And the thing didn't have any type of fail-safe mechanism in it, and it flew and it didn't come back. And this is over and over and over again, you hear these stories. And what the other thing is that there's not a lot of product support a lot of times by these vendors. Unless you start getting up into these $100,000 plus platforms, the product support is not there. So just do not rely upon autopilot if you decide to get into this. It's not a good idea in so many different ways, shapes, and forms. And that gets into know how to fly or have someone who knows how to fly. And I go back to what I was talking about before, is that RC flight simulators, there's freewares. In fact, Mission Planner has its own simulator built into it. If you're looking to spend a little bit more money, there's something called Real Flight. I think it's version 8 now. And you can choose all sorts of planes. In fact, you can go online and you can have really cool aerial combat fights with P-51s and shoot rockets, and I don't know. But it's a lot cheaper to crash in a flight simulator than it is to crash that UAV. Even if it's a $100 UAV, that $100 UAV, sometimes if hot glue might not do it, you might blow out a servo or something. Use the flight simulators first. And so one of the ideas that I have going into teaching this UAS class is that we're putting flight simulators on our computers, and one of the things that the students have to do by the end of the semester is log so many hours on the flight simulator and then be able to land and take off in a given scenario on the flight simulator. Then they're going to move to just an RC cheap airplane before they even go on to anything advanced with UAVs. But that'll give them a leg up when they go out in the world, because having someone who knows how to fly is really what's going to make the difference in this regard. So after that, buy a cheap RC platform. Get that foamy platform. And I mean, I can tell you right now that the RC platforms have gotten so cheap, it's ridiculous. One of the ways that I learned how to fly the rotorcraft is I went on Amazon and I bought something called the Hupy, and it was $35. For $35, I got the controller and I got the little Hupy, and it is great because it flies both inside and outside, and I irritate my dogs, I irritate Christina, Hupy, it's so much fun. But it's only $35. So if it crashes, you're just literally, for $5 you get a bag of extra props. It's back in the air in no time. Moving into the next point is that all missions should be conducted with a bare minimum of 2 people. It is not a good idea to do this alone. And this gets into the ethics and it gets into the safety of it, is that you really want to have 2 people there. It's not in terms of, hey, you can go all alone, you can hit autopilot and it's good. Because if we want this to move forward, it's kind of like the Polaris talk, is that when you start trespassing and the like on other people's property, you get a bad name and it's just not good. You want to make sure that in these operations that everything is going smoothly. And so you really want to have 3 people as ideal because you want to have the pilot in command. The pilot in command is the RC pilot. And the RC pilot is the one, he or she has the ability to override anything that's going on in autopilot. And there's different ways of doing it, but it's often just times a toggle switch on the computer. And so in proper protocol, what you do is you launch that thing in manual. And then when it's in manual, you're looking at diagnostics on the screen, that's the pilot at the controls. And then once it's good, the pilot in command will say switching over to autopilot, and then you say confirm, switch over to autopilot, and then you say to that person autopilot engaged. That's the type of protocol that you want. Because if anything fails in manual, you can always have it go into your autopilot and vice versa. The other one that you want is your engineer. And the engineer is more or less the eyes on the bird at all times. Sometimes the pilot at the controls might not have first-person view, and the engineer has the first-person view on, and vice versa. But that engineer is also there to where if the pilot at the controls needs to take care of something, they can get it. Because the pilot at the controls always should have their eyes on the controls. Once again, my own horror stories jumping down is just the other week, we were testing out the RV, and everything was going great. Everything was going great with the RV jet. And Max said something to the degree of, hey, we should probably not have our cell phones. And I said, oh yeah, that's a good idea. I reached in my pocket to turn off my cell phone, and I looked back up on the screen and I said, Max, it's not engaging its flight path. And apparently what happened was it was a voltage issue. It didn't engage properly into the return to launch, and it basically just glided down into a cornfield. But it was just that brief moment where I did not have my eyes on it. If I had had my eyes on that screen, it would have been a lot different. So always, always, always minimum of 2 people. It's really better to have 3. And test your equipment on the ground. And that gets, again, into, especially if you're building your own, even if you're not building your own, it's proprietary, you want to do things before you ever get that off the ground in terms of just taking a walk, to do a range check with it, to test the throttle, test the airons, test the elevators if it's the non-flying wing. All those things should be tested on the ground and before you put that up in the air. And that's where I can tell you that's one of the biggest problems that I had, is that I didn't do enough testing first a lot of times before I went up. So now that you are ready to fly, and this is the RV jet in flight, and what you can see is that in this case, this line right here, that's a bungee cord, and you pull back because there's no landing gear on this, and you just pull back on that bungee cord, and then you let it go, and it achieves its own lift, and then it gets flung into the air. Well, once you're ready to fly, build your flight plan ahead of time. This is really important to do, and it's to where when you're out in the field, there's so many different other things going on that the last thing you want to do is be rushed to put that flight plan in place on the computer. You want to have that flight plan in place where you have a good internet connection. You can have your beverage of choice next to you, and just have a nice chill period where you think it through, think about your overlap and light. It's not always practical, but even if you rough it out in the field, you can always change it, and you'll have your imagery cached on the software. I can't think of any mission planning software out there that you can't cache in the imagery. You also want to construct a written checklist, and you go over that with your team, and this is something that we've really hammered down, and our checklist has really become nice. This is another thing that I'm going to do with the students, and I'm going to have them develop their own checklist, and we'll see how they stack up with one another and what they got and what they missed. fly in an area away from buildings, cars, and busy traffic, etc. Actually, in many cases, don't do what we did here. This is where we thought that we had this thing all figured out, and what ended up happening was that the receiver on there was drawing so much power that when we had the first-person view turned on, because we never had first-person view when we were vetting it, and other times in this rural area, because we were just doing it in RC, and we thought, okay, this is all good. And then all of a sudden, we connected first-person view, we didn't ground test it, and because first-person view is involved, it sucked away power from the receiver, and it basically died in the air. And this is when that chemist had her Hupy ozone sensor in there. So what I always say is, you know, I guess it's kind of dorky, but I did grow up in the age of Star Wars, is I always say, let's just say I want to avoid any Imperial entanglements. And Max is a millennial, and so he looks at me and goes, what are you talking about? Never mind, it's just Han Solo things. So the other one is you want to have a crash kit. Because a crash kit's more than just a crash kit, it's a kit out in the field. And I actually brought in the crash kit that we have, but what you can actually get a hot glue gun on Hobby King for I think $5, and it connects to a lithium polymer battery. So you can just use an extra RC battery and plug it in, and then you can have a hot glue gun right in the field. Extra props, packing tape is another really good one to have. Packing tape is, you'll see packing tape on that thing, etc. Just screwdrivers and the like. Don't ever forget the crash kit, because sometimes I've not taken the crash kit, and then we're out there, and just once we have to drive 20 minutes back to town to get a screwdriver. So thank you. And I guess it's not a joint demonstration, but I'm willing to take questions, and I also have the materials up here. I can fully assemble the RV jet, and I also will go out in the car and get the transmitter and stuff. That's it. Thanks.
You must have applied for a co-op for your
Yes.
research, and did you have assistance in developing the co-op? That process go?
No, I was the assistant in that, and we have a COA account. And that was, this is what I heard through the grapevine, is that when I did this, it was a while back, and since I did this, the FAA has really kind of, they've tightened up on who's getting COA accounts, and we have one now. Apparently you have to have a licensed pilot and everything, and I don't really want to interject my opinion too much on this, but I think the FAA is shooting themselves in the foot on this. And the way I'm handling the whole COA procedure, when, according to FAA regulations, a COA is needed. For example, once with working with this chemist, and we fly over Lake Michigan, beyond line of sight, over 400 feet, I will apply for that COA. But until that point, because I'm flying something under 5 pounds, because I'm flying under 400 feet in line of sight, I am well within the guidelines. I'm in rural areas. I'm not putting anyone's life in jeopardy. And I don't want to open up that Pandora's box, because what happened with many researchers is that they've applied for a COA, and it's very, very harmless COA, and all of a sudden they have that locked down on them, and they're told, no, you're not going to go and fly that wetland, you just go fly this one. And they're going, no, that's not the wetland that I'm researching. So the FAA I'm not an expert on the FAA. Gene Robinson is. He actually has sued them for multiple reasons. But I can tell you that I was on an FAA call once with the Reno, Nevada test field and a couple of really big UAV providers, and talk about this stuff. And the FAA officials were all fighting on the phone. It was in this conference call, and we're all going, hello, hello, and you know, they were just fighting between themselves in terms of what the rules were. And then finally, this guy, I can't remember which company he was from, he said, we're gonna get off the phone now because you guys need to iron out some internal details, and when you got your facts straight, you can call us back. And they never called back. So, yes, we have a CoOp account. I guess is the short of it.
Okay, so your CoOp account, I've never heard of it described as an account.
A CoOp, you have to have an account to be able to log into the CoOp log to the website to file for a CoOp. So it took a year to get that, and what we had to do is we had to have our university attorney contact the attorney general, and then the attorney general had to contact the FAA attorney, and then it went back to an FAA official in our region. And what was really interesting with this is that we kept on inquiring about it, and it was kicking the bureaucratic football around, and so it took a year just to get the account.
Oh, so you never actually received an actual?
Oh no, we have the account, but I've never applied for a CoOp yet because I have not yet fallen outside of the legal boundaries of flying within line of sight under 400 feet. So as long as I'm doing that, I'm good.
Oh, I haven't seen anything that says that.
That's a
you can.
federal, so what happened was somebody sued the FAA because they were flying, and then the federal courts basically came in and they said, you have no authority on this yet. And it's definitely being interpreted in different ways, but in many ways that federal judge's ruling kind of set precedents and said, you need to establish a clear set of guidelines, and that's the congressional mandate that came through that said by 2015 you have to have a clear set of rules, which the FAA does not yet have.
Okay, I think, wasn't the FAA appealing that?
Yes, that's what I'm saying is that
So it's still kind of up in the air.
the whole FAA thing is that I've been in so many different situations where you had all these different experts on the FAA, and they're all just arguing over what it is, and that's why I'm just taking a step back and just going, I just want to dance, man. That's all I want to do.
Okay, thank you.
Yes.
If I went out and missed this, I apologize. How are you addressing Wisconsin Act 213?
Can you refresh me on that one a little bit?
I believe it has to do with drones, and there's again, I just kind of looking this up online, so other people may know a lot more about this than me, but there was an act passed last year that dealt with drones, and there's something about.
Okay, I think this is the one that, I think what it's dealing with mainly is it's dealing with first responders, and I believe that.
I think it deals with expectation of privacy, like use of drones when there's an expectation of privacy.
Mm-hmm.
So,
And I mean, this is where Christine Hupy is really good because she deals a lot with the geospatial stuff, but one of the best ways to explain that is that there are no laws out there to protect hermits. And it also gets into the fact that when I'm doing this, I'm not flying over other people's yards. I'm going over property that are in rural areas that are owned, so that these places that we're at right now, these are areas where it's just basically open public space, or it's far away from airports, and it's on private farmers. And that's kind of where I'm going with this, and I'm just going to keep on going with that until otherwise told. But I mean, you're right that it's definitely a tightrope that's going on right now. I think there's light at the end of the tunnel, and I really think it's better to, within ethical reason, push ahead and maintain our footing in the global marketplace, considering that Canada and New Zealand, Australia, Europe are getting so much in the United States. It's very important for us to where once these things are worked out, that we have the ability to move forward. Yes.
So we're going to county, my highway commissioner would love after he rebuilds or repaves to go fly a road. How far away do you think we are from that?
I would say 2015, we find out more. When they release their guidelines. But that's all I would be able to say on that. Any other questions at all?